network reads the sentence, right? This is particular text, right? So here the first word is fed into the network. So this is X. So after sending it into the network, it's basically the normal network where the hidden layers are present, right? Those calculations, the cost function will be calculated and weights will be updated, and it will provide a particular output. Then on the next step, so let's say it has a time step, right? So on the first time step, a particular single word is passed, and at the next time step, say x2, another word is passed. So the is passed, and then neural will be passed. So when you unravel it, right, when this loop occurs, right, when you unravel it, it basically spins up like a network which occurs throughout the time. So basically you are repeating the same network through multiple time steps with the kind of text you have. So that's the basic concept of like RNN. And the functions, right? You will have a function which calculates the cost, and you will do back propagation, which is another function which is used to update those weights you see here, right? So basically, the function cost function will have an activation function, which is yeah. So basically, it has the previous state's hidden state value and then the next input. So these two values will be combined, and it will be fed into an activation function, say TANH or ReLU. Those are equations where the values will be calculated, and it's used to update the weights and the next value or the new state which we see here. So here two things are done, like the forward propagation part and the backward propagation part. The forward propagation part is basically which we discussed earlier, like the function will calculate the value for the hidden layer, and then it will like go throughout the like till the end part. So while calculation, right, there will be also a backward propagation which helps us to update the weight so that the network learns itself. So think if you want analogy, think of it like a path, like a map. So when you go on a particular way, right, which is a wrong way maybe, so you will know it's a wrong way since you haven't reached the goal, right? It will compare the end goal, and then when we come back, right, uh, it will basically um, yeah, you will know that the path is wrong, and you will get updated by yourself. So you will not go that way. So you will take another route. Then if this thing repeats till you get into the right route. Say if you reach the right route also, you will memorize it, right? You will know that did you take the correct route, and this steps repeats throughout the process of training a particular model. So this is what happens, like on an analogical point of view. This is what happens on a forward propagation and backward propagation part. So you see here, right, this formed out like to give you an idea of it, right? It is basically the dot product of your weights and hidden layer values. So here you can see the x is an input, and this is the weight from the x. So basically you see w's here, right? Those are the weight values which you have. There will be also a bias value which will give certain degree of adjustment to the model. So this is it's basically a dot product and addition. Then it's passed into an activation function like TANH or the other function. So this function over here will be how this function is used in this implementation, right? So basically we'll stack these two matrices on top of each other, and then do a dot product so that we don't have four matrices, and it will increase your time cost. So it's a basic analogy on your RNN implementation. So yeah, that's the hidden layer calculation, and this is for the output for each time step. So this output will be passed through the next input. So you will have an output, right? It will be passed to the next input, and then it will help on like updating the values for the next time step. So when you see progress towards the time or progress towards the words, right, you will have a basic understanding of previous data, and then it will help you to improve the model. The model basically learns from previous utterances, and then it will capture few data. So I'm particularly like explaining it in the way of sentences, text recognition or something. So it can be applied on various levels of fields. So like I'm explaining it on a single point of view so that it will be easy to understand. So then it's a basic implementation on it. So in normal neural networks, back propagation is done. But if you see in RNN, it is known as back propagation through time. Since you are also back propagating along with the time steps you have gone. So it will update weights on the previous sentences or sorry, words also. So if you see here, right, the red lines here, this is back propagation along a neural network. So along the layers you see, right, this will be the back propagation time, and along the timestamps on the each steps, there will be a back propagation equation which happens. So normally when you are implementing something on a like a package using something for a TensorFlow or PyTorch, which is a common packages used for deep learning stuff. You don't necessarily need to care about back propagation, because these will be automatically implemented. When you implement the forward propagation, all those back propagation logic will be automatically implemented directly by the framework itself. So that's one part, one less worry for you for implementation. So based on the like types of RNN, so you have like basic idea on RNN, right? So think, okay, you already have heard about these types, right? But uh, think about it on implementation standpoint of view. So if you see, right, take for example machine translation. So machine translation nothing but normal language translation, where the machine takes a particular language, for example French, so it translates into English. So it's basically a translation done by machine. So if you want to implement a language model for it using RNN, so think of it what kind of architecture it might be. So both the input text and the output text can be a varied length of sentences, right? So your input may be of 10 or 15 sentences, and your sorry, so 10 or 15 words, and your output may be 20 or 25, depending on the language. So if you see like this many to many, right? You have two types of many to many. One is like where you will get multiple number of inputs, and then the network, after getting all those inputs, it will process and output each translation for the word. So it's one example. It can be used in many fields. If you see like many to many, right, you can see like for example binary classification or word prediction, right? So say if you need a particular model which predicts the whether whether the word in the sentence is name or not. So in that cases, many to many will be enough, right? For each word, you will have an output, say a Boolean value, which says the word is a name or not. So it's basically a Boolean value which can be outputted for each sentences. So it comes under many to many. And in the many to one part is where your sentiment analysis kind of learning comes in play. So you will have a sentence which has multiple words, and then the output will be a single probability or single value which depicts the sentiment of that word, right? So or else the what is the classification part. So if you want a particular text classification classifier, right, you can read through the text, and you can say whether it is English. So say you are building a model which predicts what language that the word sentence belongs to. So you can pass all those sentences, and then you will have the particular output here, right? So this one to many can be used in music generations. So if you have a single particular chord, right, which is basically a single piece of uh, single time frame data from a particular instrument. So if you pass it to the model, it can generate like similar kind of music for multiple time steps, and it can go on, right? So these kinds of comes under one to many. So one to one need not be basically RNN, but it's a normal neural network. Mostly one to one will not be useful in any cases, right? In the cases of RNN. So that's like how you think of architecturing a particular RNN model depending on your use cases. So okay, let's dive into language model. So in language model, right? So already said about vocabulary. So sequence modeling is a term used basically to represent that you have a sequence of data and you have to model it somehow, right? So language modeling is a similar term where it specifically directs to the language, the sentence and the words which we use, right? So it's basically tells how we are going to represent into the network so that the machine can learn. I already said that we are using a vocabulary, right? These words will be indexed and it will be stored somewhere. And depending on the letter, the one hot coding vectors will be added, and each this will be your x value, right? This will be your input value, and then the network will process and it will provide an output value depending on the what kind of output you are expecting, right? So if this is like a problem where you need to find whether this is name or not, so it will output 1 for this Harry because it's a name, Potter will be 1, and will be 0 because it's not a name, and Hermione Granger will be 1, and these things will not be 1. It will have each will have a 0 value on top of it. So this is how like data is represented in a language model. And if you see about it, vocabulary can have like millions of words, right? So the language or languages are extensive, and we can have many data. So a thing which the implementers came with is like you can concise the vocabulary. Say you have vocabulary can have 10,000 most used words. So like all those prominent words will be available to the model, but like it will not be like too much for it too. So if you see for a decent model, right, they will have around 30,000 words in vocabulary. If you if you think about the extensive corporates who are implementing these models, right, they will have like a million uh, vocabulary size of a million words, most used words in a language. So these kind of vocabulary will be predefined, and they will like prepare it through the data preparation phase itself, and then they will use that vocabulary to index all those sentences. So each these words will be indexed. um, okay, so if you see so what happens to the words which are not available in the vocabulary, right? It will basically dish out some problems. So in that cases, we are using tokens unknown tokens, or if you want your model to know that the sentence has ended, right? So you can have EOS, which is like end of sentence token, and like you can have punctuations and like lot of things which you can include in your model depending on your user cases. It's basically like you will train a model and you need to know that a particular thing which is your model not doing, and then you will include it into the corpus, and it will be added to the vocabulary. And yeah, it's like a repetitive process where you will train a model for a lot of time for acquiring like a minimum loss value for according to your implementation. Yeah. So this is like the basics on language model. So yeah, let's come to RNN. So as I said, your previous output will be the input for the next one, right? So say your output, okay, say you are implementing something like uh, a character level RNN. So here in this use case, right, you will have multiple characters, and you can have uh, word level RNNs also. Normally, the sentiment analysis which you usually see will be a word level RNN, because character level RNN won't be much useful for sentiment analysis, but it can be used on other things like suggestion, text suggestion, keyboard suggestion. These kind of things can be useful. So if you see, like told you, like you can have like 10,000 word vocabulary dictionary kind of thing. So your output will be basically in this use case will be 1,000 pieces of softmax, where the softmax output will have 1,000 values. Softmax is basically like a probability value for each each value available in your vocabulary. So it's basically telling that whether this particular word is the output, right? So all those values in your vocabulary will have a particular output value. So based on the output value, you will determine which is the like output for a particular layer. Yeah. So that's what RNN model output looks like. And yeah, this is like a basic implementation on character level RNN, which is like initially I told you vocabulary is something which can be built with words, right? It can also be built with characters when you think about a character level RNN, so that each input will be a particular letter in your sentence, and then it will calculate values for it and pass to the next letter. So it will move on that manner. So if you think about it, your vocabulary should be the letters, all those letters available in that particular corpus, right? And all those punctuation signs and spaces, and even the unknown letters, maybe if it is available, unknown characters, tokens. So that must be your vocabulary part. And yeah, so that's the basic processing which needs to be done in character level RNN. I can show you like like basic processing on it. This is like a package. So if you see here, right, it's basically all those ASCII characters which are available, and then you are using it to build your like vocabulary part, and then this particular vocabulary is loaded into your data sets, and it's used in the main like model which we gonna see now right now. So okay, I'll take few minutes to talk about the Torch library, PyTorch library. It's like when you see about deep learning implementation, you will have PyTorch and TensorFlow, which are the topmost library implementations for frameworks for deep learning. So PyTorch is like the easy one to debug, and like it's extensively used for research purposes. So rather than TensorFlow. So here, if you see, like you can see all those package imports for PyTorch, all those functions and transforms. Like these are like they have inbuilt data sets for it. Now, inside them. If you like want to use them, like the most popular data sets, we can use those things. And yeah, the all those neural networks which you heard, right? All those will have an they will have an implementation on the PyTorch library, so that you need not implement the whole model layer by layer, and or not all those equations and stuff. So these things will be implemented in those libraries, and you can like you can add few layers by taking an abstract part of that implementation. So I'll show you like few of those details. And yeah, so this is the basic inputs which you might need. So it's just for plotting purposes, matplotlib. So if you see here I have downloaded the data, basically you need a data, right? So I'll show you the data set which we have. So this is the data set, and here we have like names for surnames, which is the last name for each country. So based on it, like we are going to predict whether the particular name is from a particular country or something locality. So if you see this particular data set, right, um, we are just inputting a particular value, names person's value, which is just a word, and multiple characters inside them. So this character level RNN is much more useful in these kinds of implementations. So yeah, so okay. So if you see here, this is the basic RNN setup. As I told you, like all those models will be available. So here we are using an RLL, RNN, like importing an RNN and taking an abstract concept, or like inheriting all those equations and stuff. But we are also like adding few layers on top of it. So like you can see like there we are initializing a hidden layer, and then linear layer which takes the input size and then like passes to the hidden size, hidden layer, and then from hidden layer to output layer. So it's basically layer two layer RNN, and which will be processed throughout the time, right? Like for each word, one dimension, it basically says like whether which type of country it belongs to, right? So yeah, this is the basic implementation. So if I want to like go through more on it, like you will basically implement the forward propagation. So it's basically says you are moving through hidden layer, then to like output layer, and then the final output will be a softmax layer through which the output is shown to the uh, user, right? So it's the basic forward propagation implemented. You can see we haven't implemented backward propagation, and then backward propagation will be done by the framework itself, since backward propagation is a similar concept, uh, like uh, uh, on based on whatever forward propagation you are doing, right? So that's the one thing we don't need to worry about. And here we are loading all those categories of regions we have, and all those letters and stuff. So we are passing the number of letters, hidden layer numbers. We are initializing a particular RNN which we implemented. And then here is like okay, I'll leave this part. This is like for one step, this is implementation, so I can also tell it about you. So basically it inputs a single character. This is the input tensor which we are giving, and then it is passed to the RNN model itself, and then it will output your next hidden layer. So from the hidden layer, it will be outputted to the next timestamp. So yeah, so if you pass on a word like this, right, it's basically you are like taking each character by character and then passing it through into your model. So that's a basic basically how it works. So yeah, so here you can see, right, from character to index, you need to change from character to index, because you can't these models can't do calculations on letters, right? So basically you are indexing all those vocabulary, and then you are passing those index values, and then after processing it, right, you can from the index you can get back to the vocabulary which you need to get as the output. So yeah. Oh, that's it. Like basically, you'll be defining the loss functions, and then the learning rates and stuff. So these are known as hyperparameters, and you will change this value eventually based on your output. So training a model will be like you will train like multiple models with with slightly varied hyperparameters. So you can see which model performs better, and then you will like based on the better performing model, you will further tweak some hyperparameters to get an good results on the loss values. So yeah, so you can see like based on the line, right, sentence we have, we are taking each characters and then we are parsing it. Uh, so yeah, this is what the training phase is basically. So you will do all those steps and then the backward propagations are done. And if you see the output, right, like these are basically like printing those outputs. So I'll get into the outputs so you can be more clear. So if you see the output, right, like it's doing it on epochs, right? But it will take buckets of values and then it will process those values, since we have large data sets, and it will do on particular buckets of value. And yeah, so you can see like initially it's making a lot of mistakes and then it's eventually learning, right? So this particular part 2 point, this is the last value which we got from the last function we have. So basically it's like getting reduced on an average. So if you see here, it's getting less than like 0.4 something. So initially it was 2, around 2, if you can clearly see it in the graph. So your main objective on training a network would be getting the loss function to output a less value. So that it basically means that your model is performing better based on the test cases. So on test cases, so your model is learning more and more about the inputs you have. So if you see like yeah, I think it's run. So if you see say I have a Dutch word here, when I copy it and like it's when I run it here. Okay, so okay, now I need to run it again, so it might take some time. So I'll move on to the next parts, and then finally, if we have time, I'll run it again and I'll show you the outputs. So it basically predicts like this. So this will be this will be name, right? This will be the prediction which the model have done, and based on it will check back through the all those layers, sorry, all those text files and data sets we have, and it will say whether it is correct or wrong. So like since we have like a less value, right, our model will predict like nearby. You can like at least guess whether the model is learning based on its output, right? Sometimes you think it's like a Japanese name or a Chinese name. It will like come around those values, nearby values. So like yeah, if you want like further more results, if you want to do it in a production kind of environment, and if you want to like implement it in apps or websites, you will be running like parallel models everywhere, and in the cloud, and you will get all those results. You will check which parameters is better, performing better, and which has the less loss value, and you will use that model, you sell that model, and you will implement it in the like, whatever production environment or application you have. So this is like the RNN part. I have a basic so how much time we are at? So okay, okay, fine. So I have a like basic implementation on how we are processing data for LSTM and what is LSTM. So this is RNN part. Like I'll like to take a breather here, and if you have any questions, we can chat about it. I've been talking for so long. Mm, am I audible? Hello. Hello.
Yes, sir. Audible, sir.
Okay. Uh, so I think it's hard time. If anyone have questions, we can discuss about it. Okay. Okay, maybe I'll start through the next one. Feel free to stop me anywhere, and if you want to chat more about it, we can. So, okay, so we have RNN covered here on a basic level. So, okay, let's see. What is LSTM and why do we need it? So, like RNN is a general term where a neural network is recurrently run, right? That's what the name defines. So, here in RNN, we have a basic only two problems which are important. One is vanishing gradients and exploding gradients. As Ma'am previously said about it, like it's basically your gradient values which are like calculated from the propagation and stuff. It will dish out an extremely large value, or it will like basically um, will not output enough value for your sequence model to remember the previous steps which it learned. So say like you have this sentence, right? So you have, okay, this sentence. So you say the cat is a beautiful creature. So this particular part is basically dependent on this one, right? Like, that's what like the English grammar is basically about, right? It depends on the subject and stuff. So you obviously want your model to learn about it so that it can better perform. It can learn those things and give you better results, right? So like this sentence can be very big, and the distance between these two things can be big enough for the model to forget all those important details. So basically, vanishing gradient is a particular problem where when you progress through each sentence or each word or each character, throughout the particular time, all those things it learned about the model, right? All those things it remembered about the previous words, it will get diminished. So based on the gradient values, all those values will be stored in the weights, but it will get diminished around the time when you go through a large enough data. So it was a particularly important problem in RNN. Um, that's where and also the exploding gradients, but exploding gradients is like a little bit easy to solve. So like vanishing gradients is a bigger problem. So based on since it is a bigger problem, two new models under RNN have been prepared. So you have we have a GRU, gated recurrent unit, and LSTM. So GRU is less performant than LSTM. So but both these things are based on the gates. So the concept of gates and cell memory have been implemented. So basically, your RNN will have a think about of a cell. So basically, if you see a particular layer, right? Sorry, not layer, like a particular timestamp. Like it's usually represented as a cell since you are doing it for multiple time steps, right? So in diagrams you could see these kind of cell representations. So basically what happens is this particular cell, they will include another variable which is the cell memory, and they will take few features with the cell memory, and they will have a gate value which will decide whether the memory should be existent or not. So whether after it progress through few words, right, it will decide whether this particular knowledge about this sentence is necessary or not. So based on the knowledge, it will decide whether we should store the particular cell value throughout the sentence or not. So that's the basic two concepts which were implemented in LSTM. So you can see it's more similar like RNN. So you can see those weights and dot product of weights and hidden values and the input values. The extra one thing here is the gate values. The gate values is nothing but think of it as like a variable. which think of it as like a Boolean variable, not exactly the same implementation. I would give you a mental thought on it. So think of it as a Boolean value. It will say whether the cell value is important enough and whether you should store it or not. So you can see like we are calculating the forget gate and output gate. So based on it, the cell candidate is like a value which is good enough to store, but you still not saved it. So based on this particular calculation, it's basically like the weights, right? I told you the map analogy where you will go through a path and like you will remember it is, whether it is not good enough, and like you will save it to your memory, right? So in similar manner, it will store a particular extra value, which is the cell value, and it will store it in, whether it needs that memory or not. So like it's basically a dot product of weight into another particular get value. So think of it like that. So like but these all these equations will be pre-initialized in your framework, whatever important framework you are using. So you all those things you need to think about when you are implementing a language like RNN or a neural network. You just need to decide how many layers you need and how much what are the parameters you need. All those things will which you will initialize in your models. So yeah. um, Okay, so here you can see a basic comparison on it. So basically, you will have the function which like you had two equations in RNN, right? Which one which decides the hidden layer value and one which decides the output value. Here in LSTM, you will it's a bit more complex, but just think about it like you will have a function for a forget gate. So you can see here, right? So it will calculate a particular value, and then you will do a dot product with the input gate. Input gate, and then as the cell learns through it, right? The memory which is stored in it will help. It's the basic not basically it's the knowledge about the previous words, and then it will be utilized in your upcoming parts of the sentence or language. So here I have a basic implementation on it. So like I'm not going to run it. I'll like explain the code part on top level. So basically, you can see all those imports, torch imports. Those are torch is as I said, it's the PyTorch library. It will have like basic functions which are need for data preprocessing, and torch text is a sub package of the library. So it has multiple useful functions which are used for textual encoding and changes. So yeah, it also has data sense and stuff. So you can see like this torch has a vocabulary, right? I told you need vocabulary for implementing RNN. So it also has the vocabulary related functions. I'll show you how it works, and then you can see the splitting, tokenizing functions and all. Also, all those functions will be available on in the like documentation of the library, and like we just need to find whether it is like outputting the correct value, and we can use it in our. So here these are the hyperparameters which I said. So you will initialize the vocabulary size here. So yeah, how much words you want to save, how much learning rate. The batch size is like you will like take a batch of your input data, and then you will like do the processing. You will calculate few values whether the batches whether the model is learning good enough. You will calculate all those loss functions and graphs, and then you will go back to the next batch, and then since it has a few knowledge about the previous batch, it will try to understand the next batch, so that this batch kind of training is usually done in neural network, and then the whole after the whole batch is completed, we will have a particular number of epochs. We'll like train again on those all those datas, and then see whether the learning is done. So okay, so like GPU is extensively used for machine learning training because it's much more faster than CPU you have. So like these frameworks have GPU implementations in them, which can run both on depending on your input, right? On your hardware, it can run on both GPU or CPU. But GPU is like much more like equipped hardware for those kind of calculations. So you can see like a lot of machine learning enthusiasts using GPU to train their models and stuff. So yeah, so you can see like here we are like making a folder for a data set, and then you see here IMDb data sets, which is like data sets which has movie reviews, and then all those rating for it. Like it's basically a sentiment analysis data set. So if you want to implement this also, you will have like many to one kind of architecture, since you will have a large text where each sentence will be calculated by the model, and then it will output a single value of sentence sentiment based on the sentence. So yeah, this is like coming directly from the PyTorch library, and then we are doing a split of our training and testing set. Usually there can be a split for validation set. So yeah, based on your requirement, right? You can based on your data and how much data you are available, you can do like 3-way splitting or 2-way splitting. So yeah, here you can see we are preparing tokens here. Like I'm doing like a normal line split where each word is separated. So you can see here like the initial text is separated into each words. So this is how like basic tokenization part is done. We have like much more equipped packages. Spacey, I think Spacey is a package. I have a few implementation below. Like code below, I can show you that. So which does more reasonable tokenization, because like you can have like multiple things in the English language, like numbers and symbols and whatnot. So here like it's basically each word is taken in account as a single token, and yeah, you can have a much more complex tokenization part in your model. So here you can see the training data which I have, right? Like we are passing through it, and we are tokenizing all of it, and you can see here it's telling whether we have positive or negative. So it has two values in this label in this particular case. So POS and NEG. So these are the two labels which we have. So yeah, and then here am creating a vocabulary. You can see the unknown token, which I previously said. So we might have a word which is not available in our vocabulary, and like our model would not know like what to do with it. So here in this case, we have like built package support for creating vocabularies. You can see. Make you space for it. So if you see, we are creating a counter, which is like Python function to calculate the frequency of your whatever words in your array. So it will do like the word, and then the number of occurrences which it has, and then we are converting it, we are sorting it, and taking it for the like most occurred words, and then we are like making a tuple out of it. So with the word, and then with this like whatever size we have, sorry, frequency we have, right? We are making a dictionary out of it, and like we are passing it into our vocabulary. So here we can mention like the special tokens like unknown token, or like it is this framework is equipped enough to find those tokens. So we can also mention like punctuation and stuff if you need on the special tokens. So it will create basically create a vocabulary here, like I'm moving it to the GPU. So that's why this two a particular device you can move it. If you have like multiple GPUs, you can mention which GPU it should run, and those kinds of things. So and then this is the default index. So if a particular index is not there, and you can dish out a default index. In this case, it's -1, I guess. Mm, yeah, -1. So yeah, basically it's like here itself the vocabulary is created though. So this is all for just showing you like what happens. So this will not print an error in this case, since we have set up the unknown token, otherwise it would print an error. So yeah, so this is for a similar manner. This is for a label. So you have just have two values in the label. So we'll just have the label value POS, and then the occurrence, or NEG, and then the occurrence. You can see here. So I'm just printing it out. So these are all the inbuilt functions from the vocabulary subpackage. So it basically like tells what your index is from your from the word, or like from the index to the word, or word to the index. So you can do those kind of things. You will need those things when you are checking the output, right? So yeah, that's one part. Yeah, so then yeah, this is also like a simple function from the package itself. So you're basically implementing it. So it's just splits your word, and then it builds numerical all those vocabulary from it, and then we are using it to like yeah, you can see here, right? We are creating one hot vectors from all those functions which we have. So we are creating one hot vectors, and then this is the size of our single value, sorry, single x value batch. And then yeah, this is the our vocabulary size. And uh, yeah, you can implement your own data sets if you are having your own data sets, and you can do uh, like implementation of your own data loader, which is like the class which provides you uh, the splits and the batches of data which is needed for a training part. So data loader is that part. And yeah, this is the model. So basically it's an embedding layer, which is the initial layer which we have, and then the LSTM comes directly from the library. So basically it just has another single layer, and then we are outputting the thing. So it is also like a two layer language model. And since it is LSTM, and we are doing it across the time, right? It will be much more effective than normal layers. So yeah, you are creating a model, and then this is for yeah, yeah, basically your text and labels will be passed through the model, and then you will calculate all those losses and training accuracies. Like I can't run it now, like because it will dish out some errors because of the interpreter. So yeah, I'll clean it, and I'll put a link in the chat. Can look into a reference for later. Yes, that's it on my end. So I have few references if you need few courses and stuff. So I think it's up for questions now.
So thank you, sir.
Thank you.
So do you have audience? Do you have any doubt, participants?
Dear participants, hope today's session would have extremely more informative and valuable. If you have any queries regarding this concept, you can ask our resource person. Please raise your doubts if you have anything regarding this concept. Please ask. Sir, can we quit, sir?
Okay.
Okay, sir.
So,
Thank you so much, sir. Thank you so much for spending your time for us. It was really an extremely, we have learned so many unlearned things from you. I think, uh, like whatever Uma ma'am taught, the thing that we visualized from you, because of you only, it's been a great pleasure from us, sir. Thank you.
yeah, thanks, Many. Thanks for everyone for inviting me. Thanks to all the staffs and yeah, thanks for hearing me out. Mm, yeah,
Thank
hope
you.
it helps.
Thank you
Thank
so
you.
much. Okay. Dear participant, we have lunch break now. So I insist you all join by 1:30. We have one more session remaining. You all join by 1:30. So after one second. Okay, we have next session by 1:30. So I insist you all join by like correct time. Thank you. Now we have the